Hi folks, we're going to take a look at number 17 from the cumulative calculus review. So here we have the question. We have 750 meters of fencing and we want to enclose a rectangular area. So first and foremost, let's start our diagram. So here's our rectangular area. Okay, however, it says here that they want to divide it into 4 pens of equal size with fencing parallel to one side of the rectangle. Okay, so it's important they told us this, that the fencing is parallel to one side of the rectangle. That means we've got to draw our enclosures in that direction or in this direction. The fencing has to be parallel to one of the sides. So I'll draw it horizontally like this. So try to draw it into 4 equal pieces. Okay, and what they want is the largest possible area for each of the 4 pens. Now since they want the area for the individual pens, what I'm going to do is I'm going to call this measure length and I'll call that measure width, so that when I'm calculating the area, I'm automatically getting the area of the small pen. Okay, plus we'll see that it'll make the algebra a little easier. Okay, so what we want to maximize here is this area. Okay, so this is the relationship we're going to be working with. However, as we often have, we have a function for area which is given in terms of 2 variables. Okay, so this is where we're going to use that other piece of information, the 750 meters of fencing, to try to do a substitution. Okay, so the fencing has to enclose the outside plus cordon off the 4 pens. So here, if I'm looking at how much fencing is used, well, I've got 1, 2, 3, 4, 5, 6, 7, 8 of these L measures, okay, plus 1, 2, 3, 4, 5 of these W measures. So plus 5W, and all of that will be equal to 750. Okay, so here now I'm going to isolate one of the variables, and I'm going to isolate the W because I think it'll be easier to divide by 5 here. So we've got 5W equals 750 minus 8L, and then W is equal to, so 750 divided by 5 will be 150 minus, well, 8 over 5, so 1 3/5, so that'll be 1.6L. Okay, so now we can take this and input it into our equation for area. So L times 150 minus 1.6L, and so area is given by negative 1.6L squared plus 150L. Okay, and here we see that we've got a parabola that's opening downwards, so we know that this is going to result in a maximum value. So just want to remind you that you always have to confirm in some way that what you're finding is a maximum or minimum depending on what you're looking for. So here I'm going to reference the fact that it's a parabola, okay, as opposed to checking the signs of the derivatives. So let's find the derivative here. So 2 times 1.6 is 3.2, so negative 3.2 L plus 150. Of course, we've got to make that equal to 0. And so here, solving for that, L is just going to be equal to 150 over 3.2. Okay, and let's calculate that. Won't do that one in my head. 150 divided by 3.2 is equal to, say, 46.9. Okay. Okay, and now I'm going to reference the fact that this corresponds to a maximum since it's a parabola opening downwards. Okay, max since parabola opens down. Okay, the other option is, of course, to test the sign of the derivative to the left and right of the 46.9. Okay, so now we have the length measurement, and we can go ahead and find the width measurement. So here, W is equal to 150 minus 1.6 times 46.9. Okay, and let's see what that's equal to here. So here, I already have the 40, so I'll just redo it. 150 minus 1.6 times 46.9, and there we go, 74.96. Okay, now of course what we're looking for, in fact I just realized is not the dimensions but the actual area. So what I could have done is just taken this 46.9 and input it into the area equation, but since I found the length and width, I might as well use that to find the area. Okay, so 74.96 times 46.9, and that's equal to 3515.62, and here this is meters squared. Okay, so just a recap here. Let me pan out so that you can see the full solution. First thing is to draw my diagram, use it to help me set up the problem. So in this case here, working with area, needed to do a substitution, do the calculus, and make sure you answer the question that was posed. And very important, you need to justify that what you're finding indeed gives you the optimization that you're looking for, in this case here, a maximum. Okay, that's it for this one.